Hello, so today we're going to look into assembling a product. So before, in the other video we talked about the three things you have to keep in mind. Is this the line that you're working on, your assembly line? Do you have human operators in it? Is it semi-automated or is it fully automated? Those three make a lot of difference between what actually happens when you're trying to balance the line or study the workflow or create worksheets and all other things in the line. So it's good to know exactly what components are going to work on that line. As you will see when you compare this to the other video, there's a huge difference between the two. So last time we talked about when you have human operators, you have to make sure that you're using human beings to what our strengths are. And I mentioned our strengths, and the most powerful still we have up to now is still variation. Machines are catching up, but it'll take a while before you can let a robot assemble your IKEA furniture. It's not going to happen anytime soon. So that will keep us employed for quite a while. But I don't know. Down the future, it'll be a different story because machines do excel at repetition. You can say back in the past, it used to be mastershipers and apprentice. It was all about passing skills to another person, and every item that was built by a master and apprentice was always different from the other iteration. There's always going to be differences in the products produced, but now with machines you can get the same thing repeated over and over as long as the same conditions are applied. So machines, unlike people who can when they see differences they can be able to adapt to it, machines will take a while. If it's not within the purview of their programming, it's not going to work as expected. But on the other side, humans get tired, they get sick, they call in sick, they get in fights, they have different moods they bring to work, and they're weaker than machines. But when you look at a machine itself, I mean, they don't have healthcare, they don't have anything to worry about. They don't call in, they'll always show up as long as they're being maintained properly. So, and they don't even have a complaint department, but that will change with the way AI is working. But you can see the advantages of having machines in your line. So let's look at the same toy model that we did last time, but this time we're looking at it in terms of automation. You will notice there's a few key differences between this design and the one that was designed for the human operator with semi-automation. As you can see, the number of pieces have gone down from quite considerably. There's no more fasteners that you can see, just the main pieces, the brackets and the wheels. So you will see why that changed. So look at the material list. It's less. We only have the wooden car body this time, and then the wooden wheels coming from Woody's. We already have a good plan with them, so we'll keep that relationship going. But what we changed is from our vendor, we decided to get uh, instead of getting the metal axles and the small little brackets that we have to screw in 8 different wood screws into a piece of wood that repeated all over the times. There's always slight changes. Not every operator is really good at working on those stubs, and that's a lot of tedious work that somebody has to do over and over and over. And we want our operators and employees to be the happiest, so we decided to get a contract with them to just do the end, to do the plastic molding, change the design of the bracket. That way it just, the axle fits right through it. And what we'll be concerned with is our end, because we get a good deal of wood from Woody's. We can just work with them and continue putting the supplies in, the wooden stuff. And then instead of using fasteners, we're just going to use glue, which will be easier to automate compared to doing screws. The equipment list, this time it's also shortened quite a bit. The only thing that the operator needs this time is a switch pendant with all the controls that are pertinent to the process. So this time the station will be changed a little bit, because the operator is not going to be involved as before. The first thing, we'll have a clear glass so they can see what's going on. Just before, the conveyor will feed the station and then release it, but it's out of the operator's control. He's no longer the linchpin of the system. He's no longer the bottleneck that determines what how the parts flow in and flow out of the station. So his only role is to make sure there's a pass fail, like in case the glue is all over the part or something like that, like the machines did something wrong, then he can be able to send that part into the other conveyor, which will send the stuff to the defect zone, where we can recycle it and reuse it for something else. The pendant will have to be lightweight, because he's going to be holding onto it for quite a while. This time we did we'll have the cheat sheet packed at the back, so you can know exactly what to do in case something minimal happens in the process. That way he doesn't have to call maintenance all the time. But at the same time, we'll have an add-on system that can call maintenance in case something severe happens. And as usual, we'll have an e-stop just in case something goes unexpectedly. Proper lighting and ventilation as usual. And with COVID, we'll have hand sanitizers and extra masks next to the section, to the station itself. So the flowchart this time, there's no feedback loops in this one, because it's just straight. The machine just decides what goes down. The only or statement here is the defect, but this time it's determined by the human being, and he doesn't have to feed the part back into the process, so it'll be straight down all the way from start to end. And then now I'm going to give you a description of how this will work. The first step was before will be to initialize the system, and all you gotta do this time is to pick up the pendant and press start, and then the machine will start working. It'll pick the wooden bodies from the wood end, bring it in with the conveyor, place it in the right position. Glue will be poured into the holes, so you have to watch in case the glue is spilled outside of where it's supposed to go. And then the bracket axle combination will just be placed there by the robot, and then all the robot will do is push it down to make sure the glue sticks, and then it'll turn it to one side. The wheels will be dropped into the axles, more glue will be poured, and then another part will come in and squeeze in some plastic tabs to close that side, so the glue can dry peacefully in there and keep it away from spilling outside. Flip it and do the same over on the other side, and then it'll confirm that the wheels are spinning okay, and your job as the operator will to make sure that everything is working great. And if you see any of the processes out of the normal, you can go ahead and stop it. You feel free to stop the line and call in maintenance to come and look at it. You have that strength with you. We just want to make sure production keeps on going as smoothly as possible. As you can see, this is way better and more comfortable than the previous process we had before. Feel free to look at the other one. You can compare the two and decide what inputs you have. We can be able to change this, but I appreciate you being here. And thank you for watching this. I hope it'll give you a heads up on what exactly needs to be done. And thank you, and have a nice day.